So we're going to start with our new unit, or our first unit, which is quadratics in vertex form. How many of you know what quadratics are? What's the difference between linear and quadratics? Quadratics is 4 dimensions. Why 4 dimensions? Yes, but quadratic is actually comes from the power of 2. Okay, so quadratic is so linear function, right? With linear, we used to have y equals mx plus b, where x is power of 1, yes? Okay, when we are dealing with quadratics, our exponent is actually going to be our formula is going to look like this, where the highest exponent is going to be 2. Okay, so quadratic means exponent 2. Okay, so there's multiple ways that we can write quadratic equation in. This is one of the ways, and we call this, we're going to talk about these later on, but we call this form the standard form. We also going to have, which is we're going to cover in the first unit, what we call the vertex form. And the vertex form look like this. Now, yes, you see letters. Don't worry about the letters. We will explain them later. What I want you to worry about is now the degree 2. Okay, you see how the degree 2 is right here. We can expand. We'll talk about that later. And then that we can go from this form to the standard form. And we also have the factored form, which looks like this. You don't see the square, but because I have a multiplication and I can actually FOIL, right? Once I FOIL, I'm going to get x squared because x times x is x squared. And this is where I will see the square. Okay? So in this form, yes, you don't see it yet, or you don't see it in the factored form, but it is actually a degree 2 if I FOIL. Okay? So these are the 3 forms that we are going to explore. In the first unit, we are going to mostly focus on the second form, which is called the vertex form. Okay? So quadratics have a degree of 2. Also, right, we're going to look at how we can graph quadratic. All right? And to graph quadratic, the form or the look of a quadratic function, does anyone know how it would look like if I'm going to graph it? A U shape, yeah? Is that what you're trying? U shape, or it's called a parabola, okay? The name for it is a parabola. It could be a U or it could be an upside down U, right? It could be like this, but the shape is called a parabola shape. Okay, it all depends on the direction of opening. Can I see this? I gave you the wrong one. Remind me to give you the other one. All right. So let's look at our lesson for today. So our lesson for today, we're going to explore different kinds of function, and then we're going to look at them and see how these functions are different, and we're going to see how we can model a quadratic relation. So our first example says that the distance traveled by a boy on a bike is modeled by the equation y equals 3x. Okay, so the equation is given to me, and the equation is y equals 3x. Looking at this, can you tell me if this is a linear or quadratic? It's linear. And why is that? There's no squared. Yes. So it's linear because the degree on that x, yes, it's not there, but it's an invisible 1. Okay? So I can, by looking at the equation, I can say that this is a linear function. Or linear equation. And I know that because it's a degree 1. Okay? So there's a degree 1 here that I don't usually write. Now this is me looking at an equation. Okay? What if I have a table of values and I want to figure out from the table of values if I actually have a linear equation? Okay, so table of values, I always have x and y. We did that earlier, right? And I told you that. We're going to see that again, right? So the x values are x values that you pick or they give to you. And the y values, you can find them using the equation. Okay, so what happened here is that they took the x values and they plugged them in for x because they know that y is equal to 3x. So to find what y is, they did 3 times whatever the x value is. Okay? So in this case, 3 times 0 gives me 0. And then for the second one, 3 times 1, because x is 1. So 3 times 1 is 3. Are we okay with this? Then, for the third x value, which is 2, they did 3 times 2, which is 6. X value is 3, so 3 times 3 is 9. X value is 4, 3 times 4 is 12. Okay? So these are the x values, and these are the y values, okay? Given the equation y equals 3x, okay? Now, that still doesn't tell me if it's linear or not linear, okay? So in order for me to be able, from a table of value, in order for me to be able to determine if it's linear or not, I have to do what we call the first difference. Does anyone know what a first difference is? Okay. The second and the first y value. Okay? So the first difference is I take the y values, so you see these y values here? So these y values here. Okay, what I will do is I will take y2, so the second y value, and I subtract the first. So I do 3, take away 0. That gives me 3. Then I do 6, take away 3. That gives me 3. So second y value, and I subtract the first y value. So I move from the bottom to the top. Second y value, subtract the first y, the y value on top of it. So on and so forth. Subtract, subtract. So what do you notice about the first difference that we got here? So if I look at all these first differences that I got here, what do you notice about them? They are the same, and there are 3, all of them. They're all the same. Because the first difference is what we call constant, right? Constant means the same, it's repeating. Because the first difference is constant, I can say that it's a linear function. So it's always going to happen that if you have a linear function, your first difference is going to be constant. Okay? So, first difference is constant. Yes, it is. Now, I looked at the equation, and I know it's linear because it has a degree 1. X has a degree 1. I looked at the table of value. I performed my first difference. And because the first difference is constant, I know it's degree 1. Now, if I'm going to look at a graph, how can I determine if it's linear? What shape would it have? Linear is going to be a straight line. So when I graph these points, I should have a straight line. And this is how I know it's a linear function. Okay? So if I'm going to graph this, what do I graph? I have the points x and y, x and y, x and y, x and y. Yes? So all what I have to do is I plot these points. Zero, zero. So 1, 2, 3, I went up by ones. So if I go 1, the x value is 1, the y value is 3. So 1, 3. The x value is 2, and the y value is 6. The x value is 3, the y value is 9. I can't fit the third, the last point, sorry. Right? If I have a tool here, I would have drawn this better, but I don't. So this, as you can see, they line up. Okay? They form a line. Okay? As long as I have a linear equation, it should work out to be the same things as you can see here. With the equation, it's a degree 1. Table of value, first difference is constant. Graph is going to be a straight line. Okay? Here's another example. So I have the falling marble is recorded and modeled by the equation y equal negative 5x plus 2. Looking at the equation, what can you tell me about this equation? It's also linear because it has a degree 1, right? I always look at the x value and look at the degree. Now we're going to fill out the table of values. They gave me x values 0, 1, 2, 3, 4, and the equation is negative 5x plus 2. So what I have to do is I have to replace x with the x values and then find what the y value is. Okay? So I have negative 5 times 0 plus 2. So that's going to be 2 because negative 5 times 0 is 0. Add 2, that's 2. How about the second y value? Negative 3, because negative 5 times 1 is negative 5. Add 2, that's going to be negative 3. Negative 5 times 2 is negative 10. Add 2, that's negative 8. Negative 5 times 3 is negative 15. Add 2, negative 13. Negative 5 times 4 is negative 20. Add 2, that gives me negative 18. Are we okay of how we found the y values? All right. Now, what do I do to find the first difference?
Subtract the second from the first.
Yeah. So do -3 subtract 2.
Negative.
So I'm going to have to subtract this minus this. So -3 take away 2 is -5. Right? -3 minus 2. So they're both negative. I'm going backward. How about the second one? What would it be? So -8 take away -3. -5. Look what happens here. Because I have a negative and a negative, that makes it positive. So that's -8 plus 3, which is -5. Okay? I have a -8, and I'm subtracting -3.
So you subtract the first number to the second, or you subtract the second to the first?
No, it will be, you're taking out away you're taking away the the first number from the second. Okay? So it's going to be the second number minus the first.
Okay.
Okay?
Okay, nice.
Are you putting this?
In brackets?
Doesn't matter. Show me. Yep.
But you said it would be.
I said it will be -5.
Oh, I thought you said it would be positive.
No. No. A negative and a negative here is going to make it a positive, right? So I have -8 add 3. That's going to be -5. Okay? So let's look at the next one. I have -13. I have -13 minus -8. So that's -13 plus 8. That's -5. Okay? The last one's going to be -18 minus -13. So that's also going to be -5. So what do you notice about the first difference? It's constant. Right? So first difference now I have to graph. What are the values that I have to graph? X and Y. So 0, 2, 1, -3, 2, -8, 3, -13, right? So if I want to draw my X and Y axis, I have to plan ahead of time, okay? So planning ahead of time is very important because you need to know where to place your X and Y axis, okay? If I do this, don't draw this yet. If I do this, right? Most of my Y values are in the negatives. Would I be able to fit them here? No. So I have to be careful where I'm placing my X and Y axis, okay? So in this case, I want to have my Y and my X axis up here to have more negative Y values. Again, I might not be able to fit all my points. So I have 0, 2, 1, negative 3, 2, negative 8, and this is my straight line. Are we okay with this?